I think we can start now. So welcome everyone to this IEA webinar on the National Projections Questionnaire of the IEA Energy Data Centre. So today I will be here with my colleague Scott Andrews, who has been in charge of the National Projections Questionnaire since last year, and we will be here our objective is to help data compilers that work on national projections by providing you with key concepts and give you the resources that you need to fill out the questionnaire. Also, our objective is to provide you with a platform between the IEA Secretariat and the national compilers to exchange at a working level on how to align national projections with the reporting structure of the National Projections Questionnaire. So this webinar is really an informal meeting between us. So feel free to ask questions and to take the floor and ask as many questions as you want. It's also an opportunity to exchange between countries on practices on how to report national projections. So I will stop here and pass over to Scott, who will start with a presentation, then a demonstration of the questionnaire, and then we'll have some time for question and answers. Thank you.
Okay, great. Thanks, Zakia. And so, yeah, let's get started. We're all here for the data webinar for questionnaire compilers. So this will be, some of you might already be familiar with some of the concepts here, but I'm going to start with the assumption that someone's not seen this data product from the IEA and has not interacted with our questionnaire before. So I'm going to build a lot of context before going into maybe some more advanced concepts that people are maybe less familiar with, even if you've interacted with the questionnaire. So let's get going. So the first thing that many of you are probably very familiar with is the context and the importance of national energy projections, and that's where it all really starts for us here at the IEA. And so I view the importance of national projections through the lens of answering these questions I have here on the slide. So how will different measures affect national energy supply and demand in the future? What measures support governments in meeting national commitments and targets? By measures here, they're made up of policies, regulations, grant programs, and so on. And I think the final question, what decisions should governments make now? This, sorry, excuse me, is ultimately the big question for me is that the goal of national projections is to inform long-term decisions, specifically related to energy planning and policy. So that's the first thing, is that we collect this data because of its importance in the national context. And so what does that look like? So when we ask how national energy systems could evolve, we answer the question, at least here at the IEA, and as we see in other national projections, by modeling energy flows and products under different scenarios. And here on the slide, I have some examples from the IEA's World Energy Outlook projections. And again, to reiterate, we are collecting this data because of how important they are. And so users of our database can see how measures in different countries are projected to change each country's energy mix. And then the key part of the IEA dataset, the collection that we do in the dataset that we publish, is that these national energy projections are comparable to each other and historical IEA data through the use of a standardized reporting format. So that's the value add that we have, is of putting this and asking for your help to put everything into a standardized energy balance framework. So it's very easy to compare across the different scenarios and flows that each country is projecting. Okay, so we've talked a little bit about the context. Then let's look a little bit more of what the data collection looks like for the IEA side. So we ask that compilers submit data for 3 projection years, 2030, 2040, and 2050. One of those might have to be revised soon, as it's coming up quite soon. Then we have 4 different scenario categories that we ask compilers to put what they're submitting into, categorize them. We'll get more on scenarios in a second. And the specific data that we collect, so we look at energy supply and demand data in those projection years, macroeconomic data, some carbon capture, utilization, and storage data, as well as some metadata on the assumptions that go into your scenarios, as well as how your models work. As a reminder, this is a submission requirement for IEA member countries, and then optional for accession countries. And then just a cool fact that I found as I was preparing this presentation is that This data collection is actually one of the longest running in the IEA, starting 3 years after the agency's formation in 1974. So I think just to underscore that projections have held an important place at the IEA for a long time since its inception, albeit they were quite a bit different back then. When I was reading, it was more so around oil conservation research, as well as nuclear power. Okay, and so then how is the data collected? So we use an Excel questionnaire with one file per each scenario that you submit in order to collect the data in a standardized format. The instructions for filling it out, this questionnaire, are detailed in an accompanying compiler's guide that's linked in the bottom right there. And just as a note, in this most recent cycle, we have renamed products and flows to better harmonize with other IEA data sets. So in case you're wondering why some of the names of the products or flows, if you've seen the questionnaire before, why they've changed, it's because we've done this harmonization procedure. And then just a quick note on what the timeline looks like. So typically at the end of January is when we send out the questionnaires to compilers every year. And then we ask for a submission in typically mid-April. And then on our side, we take the data and then we publish it, and we aim to do that by the end of September most years. And then also between April and September, after we've received submissions, that's when we review them and we'll send out any questions to compilers about the submissions if there are any. Okay, and then there's one now additional step. So we ask the data from national compilers, and then we also publish it online in a different format as well. So here's a cover page of the data set available on the IEA website. And we split things into two databases from what you submit to us. So the balances database is the first one, and this is exactly what you've entered into the questionnaire. This is the energy supply and demand data. Then we also publish a second data set, our indicators data set, which is where we calculate a series of indicators using the balances data that you provide, the macroeconomic data you provide, as well as some emissions data from our own greenhouse gas emissions data set. And then we put those together to calculate a set of indicators to show not only the energy and supply trends, but also trends like techno-economic indicators and so on. And just give a snapshot of what that looks like. I've put two graphs here as examples. So on the left, we show some of the indicators in the database under two different scenarios for a single country. And then on the right, I take some data from the balances data set showing electricity consumption under the business as usual scenario for different countries there. Okay. And then if we want to know more about the database, we can reference the documentation on the webpage. And it contains more information about which countries, scenarios, products, and flows are covered, as well as the definitions of those flows and products and scenarios. And then we also have some methodological notes about how the indicators are calculated. And then finally, some country-specific notes, which includes the metadata you submit to us about your models and scenario assumptions, for example. Okay, and then on to the main part of this webinar, which is looking at interacting with the questionnaire. So the first page you'll see when you open up the questionnaire is the first tab here. And just the important one here is just to make sure that macros are enabled is in order for all of the processes in the questionnaire to work. Once that's all sorted, then you just click start and everything's good to go. So if we click start and we jump on to the next tab, that's going to be the introduction tab. And here you'll find some brief instructions for filling in the questionnaire. And the piece that I want to point out here is at the bottom. And that's the color coding of the tabs, which is a handy guide. So in green, the green tabs, those are tabs typically associated with extra guidance or information or help. The orange tabs, those are the ones that need to be filled out by data compilers. And then we have the blue tabs, which here you can see the energy balances and indicator data that's going to be published in the data set if you want to get a snapshot of that while you're submitting the questionnaire. Then if we follow the next tab, this is the data import and export tab. The import buttons here are used if you wish to automatically fill the tables in the questionnaire by formatting a CSV with values instead of entering it manually onto the orange tabs I mentioned before. Instructions on how to do this are in the compiler's guide. If you intend to fill values manually in the questionnaire tabs, then you don't have to worry about this tab at all. Okay, then the first tab that compilers need to fill out is the scenario tab. And this is where all the metadata regarding your scenario and model go. And if we look at that in a little bit more detail, what we ask for in this tab is the first step is to categorize your scenario. I'd say this is the most important step for us and for the users of our database. And so scenarios on our side are meant for database users to understand what kind of scenario a country has developed and is submitting data on. And the way to think about them is they're more baskets to aid comparison and analysis and aren't meant to be like an exact fit. They're meant to be a best fit based on the judgment of the national compilers who are the ones developing the scenario. And that's why I have these questions here in this blue box thinking, okay, what kind of scenario is it? What is the intent behind the scenario? And you're asking these questions, okay, which one is the best fit? And then the next thing we ask for is to provide details on the source institution, which is the one providing the data or the questionnaire to the IEA, as well as the collaborating institutions, which are the ones involved in modeling. These might be the same institution as well. Then we ask for a description of the methodology and type of model used, some of the main assumptions and descriptions of the scenario that are going to affect the overall results, the frequency of when the next update to projections is expected, as well as some links to documentation in whichever language they're available in. And then finally, some other comments. This is where we typically see clarifications on what are reported in specific cells within the tables in the questionnaire. And we'll look at that in a bit more detail during the demonstration. And if we talk a bit more about the different scenario categories here, we have here 5 scenarios that are arranged in 4 buckets. So the first one is the business as usual scenario. And this is like the baseline or reference scenario, assuming historical trends apply in the future without the addition of any new measures. Then the stated policies or steps scenario. This is a policy-based forecast on what is likely to happen given the current energy landscape and policy ambitions in your country. And so this one, for example, accounts for policies that have been announced and not just those that have already been adopted, like in the business as usual scenario. Then we have the aspirational scenarios, and we have 2 of these. And so aspirational scenarios are the hypothetical scenarios based on optimizing policy for a desired outcome or target. And that outcome or target is how we separate these 2. So the first one within the aspirational category is achieving national targets. And these are for scenarios that are meant to achieve specific targets. So if your model is based on achieving, for example, let's say an emissions reduction target of a certain percentage by a certain year, then that would fall under achieving national targets. And then a lot of the other exploratory scenarios that are not aligned with a specific target would fall under aspirational outcomes. So scenarios meant to say optimize for renewables integration, let's say not under a specific target. And then finally, we have the other category, so those that do not fall under any of the above. And with this one, if you're submitting another category, we ask that you please provide additional descriptions of the scenario so that users can understand what type of scenario is being submitted. And as a reminder, you can submit as many scenarios as you have data available for, and we encourage you to do so so that users have as much of a look as possible of what national projections are out there. Okay, so now on to the main part, which is reporting in the energy balance format. And so before we move on to those tabs in particular where we're inputting the energy balance data, we do need some knowledge of how energy balances work. And so I've taken a compressed view of the questionnaire here to illustrate some of the key concepts. And I already have those 2 on the products and flows there. So the first maybe thing to understand about an energy balance is that it's meant to give an economy-wide picture of how energy flows through a country under different products. And the energy balance takes the form of a matrix where the columns represent all the different energy sources called products, and rows represent all the different origins and uses, which are called flows. Rows can be further separated into 3 blocks to aid our understanding, which is supply, where the energy comes from, transformation, how energy products transform into one another, and then final consumption. And then we use the terminology a lot saying energy, supply, and demand. And so when we say demand, we're typically adding transformation and final consumption together. And then the final thing to note is that everything in each of the cells of the energy balance is in a comparable unit. In our case, that's going to be megatons of oil equivalent, and this allows us to easily compare across different products and flows. And so at the end of the day, the key idea behind energy balance is that it's an accounting framework. So if I wish to understand what is reported in a specific cell, I need two dimensions to do that, a product dimension and a flow dimension. And the compiler's guide is exactly structured in this product and flow separation to help aid in this analysis and understanding what needs to be reported in the different cells. And so then, yeah, if we have questions about energy balance reporting, the first thing we always ask for users to look at is, or in this case, sorry, data compilers, is the compiler's guide. That's the main reference for how to fill out the questionnaire. And then if you're unsure how to report something in the questionnaire, even after reviewing the compiler's guide, we're more than happy to receive your questions at the email there on the slide. Okay, and now here's the first tab with the full energy balance. And this is the historical year tab. And for this cycle, in the most recent questionnaires we sent out to compilers, it's titled 2023, which is the most recent data we have for annual submissions. And so this sheet maps what countries submit in the annual questionnaires to the aggregated products and flows of the National Projections Questionnaire shown here. And so if you're not sure where to report something and you have an understanding of how the annual reporting works or have a colleague that does, this sheet can be a helpful tool in understanding where to report certain items. Okay, and then on to the tabs that are filled out by the compilers. So we now have the projection years. So in this case, the format for the years 2030, 2040, and 2050, or tabs 6, 7, and 8 are all the same. And so then when I'm going through this, it'll just show one of these tabs. So if we look at it in more detail, then the first thing to understand is that there are 3 blocks roughly for the whole balance. And the first one is the main balance block. And so that's what's highlighted in red here. And so everything from your projections output should fit within these products and flows in this red box. And also just as a note, these gray shaded cells here, they're locked for editing because they are summation cells. And so if, for example, your model outputs aggregates only for some of these products or flows, please let us know, and we can unlock those cells for you to enter directly into them. Then the next part of this balance that we have are what are called the memo categories. So these are products and flows that are disaggregated from the main balance, and are meant to do that specifically for key technologies that are becoming more relevant and common in projections. So we have a better outlook of how these are evolving. And just to reiterate, like it's a disaggregation. So everything in the memo category shown here in the lighter green rows and columns should be reported in the main balance as well, according to the descriptions in the compiler's guide. Okay, and the last part of the questionnaire tab for the energy balance projection years is the quality control checks. And these are meant to indicate where maybe something needs to be double checked on the compiler side. And so a quick note on the conditional formatting for this table here of checks is the dark blue there is meant to indicate that everything is as expected. And then the red indicates that a value was expected under a product and is missing, or that it is very much outside of an expected range. And then the yellow indicates that things are slightly outside the expected range than we expect, and then maybe something needs to be double checked in the data. And so we can look at a few more of these checks in detail just to understand what they are. So the first check is making sure that supply equals demand, according to the formula there shown on the side. And this applies to all products. And I've highlighted the cells in yellow for the coal product that are used in this calculation. The second check is just to make sure that where electricity is reported, electricity output specifically is reported in the main balance, which is in 2 places, just to make sure that those 2 match. And while it does this, it also checks accounting. It checks that the electricity input for boilers and heat pumps is also reported correctly in some of the yellow cells there. And again, like for all of this, if more details needed, always reference the compiler's guide as well. And then the next one is for heat output consistency. So it's the same as the electricity output one, except it checks that the heat reporting for heat sold matches in the two places that it was reported in the main balance. And while it does that, it also checks to see that the heat pump reporting in the main balance was done correctly as well, if that was projected. And the final thing we're going to look at for checks is the efficiency. And the one to note for this is that it is a power efficiency or a combined thermal and electrical efficiency. So it's not just purely an electrical or heat efficiency, depending on what's been reported in the balance. Okay, and then moving on to then the table asking for macroeconomic data. In this one here, just to watch out for when you're entering in the population and growth rate data, the population is in units of millions, so just watch out for that. And it's also a good time to mention some of the color coding for this in the next tab, which I've shown at the bottom here, is that the white cells, these are ones that are fillable by the user on these tabs. The gray, as with the energy balance ones, these are the summation ones that are not able to be edited. And then we have this like yellow color. This is for historical or last cycles data. And last cycles data, as in the acronym LC there in the picture, this is what was submitted to us in the last time that you had a submission to the IEA. Okay, and then the final tab for data compilers to fill out is this one on carbon capture utilization and storage, if this is in your projections. And the one to see here is that we ask for this carbon capture utilization and storage data, not only for projection years, but also for historical years if that data is available. And this is because we do not collect this CCUS or carbon capture data in other IEA questionnaires. And then the last two tabs of the questionnaire are involved the published data. So on tab 11, you can see data you filled in, all the energy balance data you filled in beside what was submitted previously, as well as historical data and some charts to view trends if you're interested. And then table 12 or tab 12 is that if you're also curious, you can see the indicators that are calculated and which will get put into our database and on the IEA website. Okay, so that was a lot of information to quickly jump through in a short amount of time. And so I'd like to reinforce some of this by pulling up the questionnaire and walking through specifically how to fill out the energy balance side in a bit more detail. And I'll look at some of the specific aspects of the reporting for people interacting with the questionnaire for the first time again, as well as some common issues we see when we review questionnaires submitted to us. So I will quickly swap over here.
In case anyone has any question with regards to the presentation, please, you can ask now or later. No question?
Okay, so I've pulled up the questionnaire here, just as, is there something you want to address?
There's a question from Ireland. In the Q&A box, I don't know if you can see, Scott. There's a question from Evan from Ireland. So in the compiler's guide, it says that some products flows have been renamed. Would it be possible to share a list of the changes to compare to last year?
Yes, I think we had not done that originally because a lot of the flows are quite similar in name. There are a few that are, I'd say, relatively different. So yes, this is something we can send out. We can add to the compiler's guide to show the changes. Yeah. I can also highlight some of that here, especially for the main ones where the name change was significant. Yeah.
Okay. So it means that we will be able to share this when? This comparison of the names?
Yeah, I can email that specifically
Okay.
to Ireland or to different data compilers. I think it's also something, yeah, especially for some of the main flows that were updated to put in the compiler's guide so that for next year and then also I can upload on the website as well. But, yeah,
If that's
I can send
helpful
that
for this cycle, yes.
Yeah, exactly.
There's also another question from Yanis. How to enter electric boilers?
So this one is a fun exercise considering how aggregated our balance is. It goes under specifically how it works under the electricity and heat product. during the discussion section, I can pull up a graphic for this and show some more
Yeah.
details on this because
Okay. Maybe
it's not
after the
intuitive and
demonstration, you
straightforward.
can
Yeah.
show.
Yeah.
Thank you.
Okay, so yeah, if we're here on the questionnaire, so yeah, just like everyone else, we're going to see the Start tab here. I've got macros enabled. I'm all good to go. So I click the Start tab. All of the tabs will now appear here at the bottom. I'm specifically interested, and I just want to look at the Scenario tab and some of the Energy Balance tabs while we're here. So the first thing to look at I want to highlight is the Scenario tab. So I've populated this just for like a fictitious country that we use a lot here at the IEA called Status Land. It's a very special country that has every energy product that you can possibly imagine. And so in this case, I've selected a stated policies scenario for Status Land in my reporting. And as I mentioned before, I've just highlighted, okay, the Status Land Ministry of Energy is compiling the questionnaire and is also the one doing the modeling. And then I provided a short description here saying, okay, we're using a times model and described it a little bit in more detail there, and as well as some of the main assumptions that underpin my steps model or scenario, sorry. So I'm saying it includes not only adopted policy, but also announced as of a certain date. And I'm saying that I'm in the EU and I'm following a certain emissions trading system price trajectory for carbon credits. And then, as I mentioned in the other comments here, I've just thrown in some examples. Like a common one we see is that my model doesn't differentiate between exports and imports, and that I'm only, when I see in the import row, this should be interpreted as net imports. Or maybe I can say that under like a certain product, certain gases are contained beyond just natural gas is one I put here. So here you can put specific assumptions related to certain products and flows that you want to highlight for energy balance reporting. And so if we jump over then to the main table, I filled this one out here for Status Land. And I just want to go through some of the products and just show how I might go about filling in the questionnaire step by step. So if we just start with coal and coal products, I could actually see here if I scroll down that I do have a checksum error here, which is telling me that energy supply and demand are not balanced. And so this might be a moment for me to just double check that I've included everything properly in the flows under coal here. And so the first thing that might be helpful for me in addressing these errors is in understanding what is actually reported under coal and coal products. And so I've actually got the compiler's guide pulled up here as well that I can swap over to. And so then if I've got the compiler's guide pulled up and I scroll down, I'm going to want to go to the section on table 1. So that's where I'm doing all the reporting right now. And if we go in the first one, so the column section is going to show up first. And here I've got coal and coal products. So I can quickly take a look at this. I can zoom in a little bit more here. It's okay. It's saying all coal and coal products. Okay, so anthracite, coking coal, I can all the way down to secondary products, coke oven coke, gas coke, coal tar, so on. And so this is just, okay, a double check, make sure I've got all these products included. And now if I want to make sure that in the different rows, I've tracked all these products and put them in the right place, I can scroll down, keep going, down onto the rows section. And just for an example, because it tends to be a more complicated flow, is that one that I always see is other transformation processes. So if I scroll down, I've got this row here and this flow, other transformation processes. And this is telling me, okay, includes transformation of energy products not captured elsewhere in the balance. Let's give some examples. And I think this is an important highlight point here is that this flow can include both inputs, negative, and outputs, positive. And we mentioned here the specific example of coking coal to coke ovens and the produced coke oven gas are summed in this row under coal and coal products. So if I go back to the questionnaire, that makes this cell quite an interesting one. So if I were to think about all the inputs and outputs that I need to report in this specific cell, assuming I have, let's say, a steel industry in my country, I would need to report the input of coking coal into coke ovens as a negative in this cell. And then I have to now add on the produced coke oven coke as a positive in this cell, plus the coal tar and coke oven gas also as positives in this cell under the same energy unit. And then I would have to do the same for blast furnaces as the inputs is negative and the outputs is positive, or specifically the energy outputs. And so this one can be an interesting flow to keep track of. And I think one thing that's handy when looking at this left-hand side of flows, is this positive or negative sign can help you understand what needs to be reported here. Like for exports, everything that's included in this cell has to be negative, imports being positive. And then we have some of these flows where for certain products or for all products, it has plus or minus. That means I can have the same in the same cell, or at least across the row. And so that's something to keep in mind. Okay. And I think, yeah, especially like this other transformation flow, like we don't have a very large definition or disaggregation of flows in this transformation sector. And so it's a lot of things fall under this other transformation flow. So unless it is involving specifically electricity or heat production or own use and distribution losses, it's pretty much, if it's being transformed from one energy product to another, it's going to fall under this row J, other transformation products. Okay. And then if I move on to the next one, peat and peat products, which we also use a lot in status land. The one thing I want to highlight here is this one right here, which is we have a negative total energy supply, which we do see this sometimes for submissions, which is not possible, especially when we have demand in end-use sectors. And we typically see this happening because of projections of stock changes. And so it's just a moment for people, if you're projecting stock changes, to just be careful that the final total energy supply is still positive. And sometimes, yeah, this can flip negative. And then, yeah, we can see we're actually using peat in the residential sector here. And this is another thing I want to point out is these indented categories here. And so for transport and road is a disaggregated or is a subcategory of transport, just as residential and commercial and public services are subcategories of other. So these two subcategories, sometimes we see that when you sum them, they're greater than the overall category, and that shouldn't be the case. These two numbers can sum to be less than the total, they shouldn't sum to be more than. So that's something to also keep in mind as well. Then if we look at oil and oil products, the one I want to point out here that we do see sometimes is, sorry, if I scroll down, you'll see, is we can look again at the checks and see that we have a pretty high calculated efficiency here of 90%. Now remember, this is a combined thermal and electrical efficiency. And if I look at these two rows here, 27 and 28 on the side, or V and W as they're denoted here, I can see that I'm not reporting any heat output. I'm only reporting electricity output and then an input to the heat, to the electricity plants here. So this is actually, then I can interpret this as an electrical efficiency, which for an oil plant at 90% is not what I would expect. And so this is something where just to check, like, because we put everything together, heat, electricity, inputs to these plants in this cell, just to make sure that these two are reported correctly and that they are in different units, right? The main balance is in here is in megatons of oil equivalent, and in this part of the main balance, we have electricity output in terawatt hours, and then heat output in petajoules. And I think, sometimes, especially if there is high proponent of heat output, these kind of efficiencies can be correct, especially also too if you have projecting some sort of heat recovery. And so, yeah, if you are projecting heat recovery, that's another one where we ask that you put in the metadata in the scenario tab or an email or in a comment on the Excel spreadsheet, just so we know that to expect, especially for those heat outputs, such high efficiencies, which makes more sense if you're including some sort of heat recovery. And one more note I'll just do for oil and oil products, just similarly to coal, the other transformation process flow also has all of the refinery input and output summed into this single cell. And that just to watch out for that. And that also explains why when we have such a high total energy supply of 35 relative to negative 1.5, why this number is so small in magnitude, because there's being a summation of positive and negative values, inputs and outputs in that cell. Okay, and another one to look at that we see sometimes under the natural gas tab here is reporting of statistical differences. And this is typically used in historical balances to track the mismatch between energy supply and demand because they're gathered from different sources and is expected. In projections, it's a little bit more like it's not so clear cut. And when we see people reporting projections, we always ask the same question, and we always say that if you're reporting statistical differences, please provide like what is being reported here. So for example, the question that we ask is this value someone projecting statistical difference based maybe on historical data, or is projecting an error in supply and demand? reporting? Or is this some residual amount left when you are allocating your outputs from the model into the natural gas product? You found that after you'd inputted everything, there was still some mismatch, and then you're just putting it in some statistical difference just to make it, because you weren't able to find where that mismatch between supply and demand was after putting in the projections data. So we don't know if that's, because you weren't able to find where that mismatch was, or if you were actually projecting statistical difference. So if you are reporting it, we ask that you please tell us which of the two scenarios or a third one you fall under, just so ourselves and the users can better understand what this number means. Okay, and just a few more concepts.
We
Yeah,
have
go
one
ahead.
question, Scott, in the Q&A box. So Zach is asking whether regarding the renamed products and flows, has the metadata labeling for said product flows also been changed? So short name, long name, maybe you can clarify this.
Yeah. So some of that, has been changed. So if you're using the CSV files, it's just something to double check. Certainly the long names, there were very few revisions to the short names. Those were already pretty much harmonized. That's again something that I have track of that, yes, can be included in an update to the compiler's guide, and I can send that out to people. And yes, mostly as a majority, like rule of thumb, the long names is what were changed. But I can highlight both, sending it out to people. Yeah.
Yeah, we usually avoid changing the short names
Yeah, I
for
think like
this
one or
specific.
two were changed. Yeah, it is more the long names that were changed. Yeah. I can just confirm that and send that out to people. Yeah.
Thank you.
Okay. So then next one is that I want to cover this concept of what's called primary energy equivalence, which this applies to nuclear all the way down here to tidal and wave if you're reporting for it, but more so from nuclear to solar here. And what you'll notice is that this indigenous production flow, they're the same number and opposite sign as what's been reported here in the inputs to electricity, CHP, and heat plants. And yeah, that comes down to this energy balance concept called primary energy equivalence, and it applies for nuclear to solar as well as tidal and wave power, specifically because their primary energy source is hard to measure. So like wind, the kinetic energy in the wind, or the potential energy of the water for hydropower. So those are hard to measure in those terms, and make it comparable in an energy balance. So I won't explain in detail what has been done in terms of making those decisions for how to for what primary energy equivalent is. But I will just explain how we can get to these numbers of eight, these positive numbers here, the negative ones under these flow, how we get there from knowing the gross electricity output of, let's say, the nuclear power plant or hydroelectric dam. And so that's also contained in the compiler's guide. So if I switch over again to, I'm actually going to use a new tab here. So if I scroll down from the beginning, and here I'm going to want to go to the units and conversion tab, which explains this concept in a bit more detail. So here you'll find some stuff about default calorific values and such for different products. But what I'm interested in, if I scroll down, okay, let's just take, I passed nuclear, but let's just take geothermal here as an example. And so at the ends of these paragraphs, in this case, we have two because geothermal could be used for electricity production and heat production, each with their own formulas for calculating primary energy or primary energy equivalents. And so for geothermal, we assume a 10% efficiency for electricity production. If you have, like, what the efficiency is, you can use that number instead. But then the formula to use is here at the bottom, is that if you take the gross electricity generation in terawatts, there's a conversion, then divide it now by the efficiency that that's what you'll get as the primary energy equivalent. And then for heat, it's going to be a different formula based on using terajoules, a different conversion factor. And in this case, we've assumed 50%, but if you know your efficiency, you can use that number instead. And so then when you have this primary energy equivalent, if I go back to the questionnaire, there we go. Then I would take the positive of that and report it here under indigenous production, take the negative of that and report it under the inputs for electricity and heat. And then that's going to make sure that everything in the balance is accounted for correctly and that energy supply and demand will be equal. Okay. And if you actually notice, for geothermal, I have 100% efficiency. So that's something I would need to go back and make sure I've used that formula correctly. In this case, I have only electricity production, so it should be, we would expect around 10%. Okay, the last one that I want to look at here is this, let's say, catch-all flow. So we have tide, wave, and ocean, and other energy sources. And so this flow is, yeah, as I said, the catch-all, and includes anything else that doesn't fit into the other products, as well as push together with tide and wave and ocean sources. And the one I want to highlight for this is that if you're reporting under this product, even if it is tide or wave energy, to please provide some metadata on what is being reported here. Just so that we can understand, we don't have to, our users, or we don't have to guess what it is. I mean, if I'm looking at this what I currently have in here, so I've got something that's indigenously produced, can be used as an input to electricity or heat plants. And I think, yeah, based on the fact here, if I read heat output, I don't have any electricity output. So then this input is entirely, we have indigenous production, input to only heat plants, some generation of heat sold, and then we also can use the same source as final consumption in different end use sectors as well. And if I scroll down to some of the checks, I can see that for this tab, I also have 100% efficiency. And so if I were to try to guess what this source is, and again, we want to avoid having to do that. My best guess is that there's some sort of purchased waste heat being reported that's being used in, upgrading heat, and then also in end use sectors as well. With this, yeah, this is again, to highlight the importance of, because of the way this product is aggregated, that we need, and our users need, more information to understand or be sure of what's being reported under this product. Okay, and the last thing that I want to mention again is the memo categories, and just to make sure that what's being reported under here is included inside the products in the main balance according to the compiler's guide. In some cases, it's quite easy to do a quick check. For example, like the disaggregation of wind into what's now an offshore wind. I can take like a quick comparison, say, okay, I have 8 megatons of oil equivalent. My primary energy equivalent here, I've got 4. And even seeing, I can look at the electricity generated, 93 versus 46.5. And I'm like, okay, that looks good. And then if we take a look at the heat pumps, I can see that in this cell, it's what the heat that's taken from the ambient for heat pumps. I can see that where it's reported in the main balance, which is under heat, and there's nothing else that gets reported in this tab except for also boilers, potentially, and then any sort of purchased heat. But that is to say that everything that's reported under the heat column, that because that's where heat pumps show up in the main balance, these numbers should be greater than or equal to what's reported in the heat pump flow. And in this case, that's not what I'm seeing. And we do see this happen, is that, and now here I've got 2 megatons of oil equivalent, but then in my disaggregated category, I've got 5. I can even look at heat generated as well. I've got 20 versus 73 petajoules. So something here is not lining up. I've either overreported in this memo category, or I've not included everything that's for heat pumps inside the main balance under the heat, as according to the compiler's guide. So just something to watch out for as well.
Scott, we have 2 questions from Yanis in the Q&A.
Yep.
Where should we report synthetic fuels in both oil and oil products, as well as in the memo column?
Yep.
Yeah.
Okay, I can take that one first. Yeah. So I can actually, I mean, since we're at this, let's pull up the compiler's guide. I know where it is, but then let's take a look. It's not, I think there, yeah, some more notes can always be added to the compiler's guide as we continually try to improve it. So if I switch over back to the compiler's guide, okay, there we go. Okay, I'm at the top. I'm just gonna, bear with me. I'm just gonna go all the way to the beginning again. So I'm now looking at energy balances. So I'm gonna go to table 1. And in my case, I know that when you're talking about synthetic fuels, in the main balance, that is going to go under oil and oil products. Yeah. So I have that here. So oil products, including liquefied petroleum gas, and so on. For example, liquefied coal would be shown as coal consumed, and it gives a certain L, as well as secondary oil production. And similarly, hydrogen or other synthetic fuels produced from natural gas would be shown as natural gas consumed. And I can show that this is the product in row for other transformation cells, a cell JD, and secondary oil production in cell JC. So yes, the synthetic fuels in the main balance would be under oil and oil products in other transformation. And then they would also then, you're right, be reported in the memo category for synthetic hydrogen and synthetic fuels, according to if I scroll down this diagram here and the description under column Q, memo hydrogen and synthetic fuels. Yeah.
There's also another question. How do we deal with hydrogen used to produce electricity? Where do we report it? Only in the memo?
Yeah, so that one, so how to deal with hydrogen used to produce electricity. So this
Electricity.
one is a fun one as well because we don't have like a hydrogen product in the main balance. We actually use like electricity to capture hydrogen use and hydrogen production. So this is a fun one. Okay, so if we go, and this is the, I guess when they decided how to aggregate all these categories, this is the solution we came up with when we added hydrogen reporting. So if I go to column M here, electricity, it's talking about, so if hydrogen or synthetic fuels are produced through car-to-gas processes, so this describes, it gives an example, like assuming a 3 megaton input of natural gas to create electricity, and we have an efficiency, and then we also have, let's say, a 50% efficiency for electrolysis. So that has to do with the output and production of it. And then if we turn around and use that as an input to produce electricity, we would also, I think maybe it actually would be better if I go to the questionnaire, because this is and this is one I might need to confirm as well. But my best, let's see if I move this over. This is, I think, one of those ones where it's going to be a summation as well. So, there we go. So if I move over, this tab here, so this cell here is where we're going to see, and I can just double check it in the compiler's guide. Hold on. This is where we're going to see the output of electricity. Yeah, because this gets a bit complicated, so I want to make sure I'm keeping track of everything myself. Okay, so the output is reported in cell IM, and then M is the column for electricity. So I would report the output of hydrogen energy units in this cell. But then, and why your question is very important is because this is also the same cell for every other product that, I mean, okay, maybe I should take a step back and explain how this works, right? So the electricity, CHP, and heat plants flow for every product except for electricity and heat. We would expect a negative number because they act as inputs. So we have coal input to electricity and heat plants, natural gas input to electricity and heat plants. But then if we scroll over to electricity and heat, these two cells under the same flow represent the output of electricity and heat. Then now we add this layer that we now need to report hydrogen in the main balance, and we're saying that we're going to report the output of that hydrogen under the cell that's the same as the output of electricity. But then now, because we're saying that hydrogen is represented under the electricity product category, we would then want to then subtract the use of hydrogen for electricity consumption from this total. So then this cell would now turn it into a summation. So we would subtract it from this cell and we would report the final electricity output in the cell here. Or sorry, so on. That's it. Actually, I don't know if we've actually run into this scenario because then, yeah, it doesn't make sense to have electricity output from electricity. So maybe rather than, let's keep going through this, let me double check because I'm also thinking too about how that makes sure we do that accounting correctly. So that's a good question. I'll make a note of it and make sure that, yeah, because and this is the challenge we have with projections and the very few flows we have set up, is that we're constantly having to interpret projections which are not based on a specific standard per se into this energy balance framework that's very standardized. And so you can see I was trying to walk through it in my head based on this energy balance framework that we've set up, how it's working. And so now I've already seen in a case where it's not. So either I've missed how we're supposed to do it in previous guidance, both externally and internally, or this is something we've not come across from.
But in the input, in the memo input of hydrogen for electricity, we have it, right?
Yes, that one's more straightforward.
So the input is easier to report.
Is why I'm thinking that I'm just missing because I am not familiar with that specific case, that I think I'm just not, there is a way we've probably done it in the past, and if not, then this is a good point for us to make sure that we've done it correctly on our side. So in the memo category, it's a bit more straightforward. I might still also have that. See if I have a nice figure in the compiler's guide. Otherwise, I'll just point it out here on the questionnaire. Okay, my picture doesn't show it very well that I have in the questionnaire here. But that might also be how we've done it, is using other transformation paths. Let me confirm that for you, just to make sure that I have it correctly on my side. I have a feeling that it has to do potentially with other transformation because of the way that we're reporting and using this electricity input flow as a production flow. And it might actually be reversed for the memo category, because in the memo category we use other transformation. So like I guess I can show that here, just walk you through it, and I think I'll make sure to confirm the answers. And I know for sure that under other transformation project here in row 15 or in row J, as it's on the inside of the balance, we can see this number 2.7 here, and this is the production of hydrogen from different sources. So that's what's being, and then I would imagine then that, okay, we have the input to electricity plants here, then this is where I would see this negative value for electricity input here. But then because of the main balance and how we're doing it, it might be a bit reversed. So I'll just make sure I confirm on both sides, in both the memo and in the main balance.
Thanks, Scott. We have another question about where should we put ambient heat used by heat pumps?
Yeah, so that one, maybe I will switch over to the compiler's guide. I also just make a note of the question on the hydrogen in the main balance for electricity. So that one, there is a picture in the compiler's guide. So I mean, first off, I guess while I'm here, I can show you. So that's going to be under indigenous production here. So under the first row, under heat, that's this cell specifically here. That's where we would report the ambient heat taken into the gross output of heat pumps. And that's reported in the same cell under the memo category as well. I know people were talking about the boiler one as well, because it falls along the same lines of why I was thinking the subtraction for the hydrogen is that's how we handle some of the boiler flow. So if I go back to the compiler's guide, hold on, let me get my mouse. I can find my mouse. There we go. Okay, so where am I here? So I'm in the column section here for table 1. I scroll down and I get to, so we have this under the electricity, CHP, and heat plants flow.
Can you zoom a bit?
Yeah, I was just going to do that. Thank you. We have this diagram here, which is, I'm thinking of remaking some of these ones here to make it a little bit more clear. But so we can see the heat extracted from ambient air by heat pumps in this top corner here. And then we were talking about the boiler reporting, is that the way we do boilers is we want to not double count anything, and we want to actually record everything in the final consumption as heat, because that's what a boiler, as well as a heat pump, are for. And so under the electricity column, under electricity, CHP, and heat plants, I mentioned that this cell is meant to accumulate all of the outputs of electricity based on all the inputs and the negatives in the previous products. And so the way we do boiler reporting and heat pump reporting is that this output here is the electricity output less electricity used for boilers and heat pumps, if you're projecting that. So we're actually subtracting that from the gross total here. And instead, where that's going to show up is I'm going to have the heat outputs, including heat from boilers and heat pumps. So, and if we assume, like, we're taking an assumption that the electrical conversion to heat for boilers and for heat pumps that we're putting in for the compressor is a 100% efficient. So instead, we're just going to, instead of having that show up as an electricity output, we want that to show up as a heat output, just to make sure we're not double counting there. And then that, ambient one shows up at the top here. And then the ones at the bottom for terawatt hours and petajoules, then we're going to make sure that in the way we do this is, again, a little bit differently. So then under electricity, we show the heat output from electric boilers, and then under heat output for heat, that's the total. So that's the electrical input for the compressor plus what's taken from the ambient is the gross output is what's put in the heat output tab here. So this picture shows it, but it's, that's, we do some subtractions and additions in order to make sure we don't keep expanding our balance to make it very small. And I think that's, I mean, some of the challenge we have on our side is that we like to make the balance very aggregated because we don't know what different projections, we don't want to disaggregate it and then have a bunch of projections that are not outputting values in those. And then we also think, having it aggregated makes it a bit easier to say, okay, I think it folds roughly under this category. But then the problem we have with that is when we do get to points where we're like, yeah, okay, we know a lot of people are projecting heat pumps and we know a lot of people are projecting electric boilers. And now we have a lot of people projecting hydrogen, and we don't have necessarily wanting to add more and more products, then we end up with accounting tricks like this. And I think eventually as some of these flows get more common, I think there can be more of a discussion on revamping parts of it and saying, okay, let's add this product because 20 out of 25 or 20 out of 28 or 32 countries are submitting this now, then we should have this as its own product or its own flow. Okay, I can bring it back to the presentation just to round out some key points on our side. I notice we've almost run to time. We can stay for a few more questions as well. Where am I here? Okay, and so yeah, just some key points from us. So just to reiterate the importance of national projection in the IEA database, of having this comparable data in this same system so it's easy to compare across different countries. Then also talking about the available resources for compilers on the compiler's guide, and I have noted down specifically, the talk about the hydrogen for electricity production, as well as sending out to everybody to make sure the long names that were changed, there were quite a few, and then I will double check to make sure which specifically the short names that were changed, which I do not think were more than one or two that were changed there. Perfect. And maybe I'm actually misremembering, maybe no short names were changed, but again, I'll double check that for everybody, and I'll update that in the compiler's guide on the website, as well as send that as a copy to everybody. The other thing, we talked about was the energy balance quality control check. So this applies to everybody, and using that table below the main balance, this also is something that we check on our side. So if you look at it and you notice something, it saves a bit of an exchange. And then finally, like the last thing, as we want to do more of these webinars and also be able to answer your questions, is that, please reach out to us. We're here to help. We're the ones that be the custodians, let's say, of this energy balance accounting framework. That's what we understand. So if you're more focused on projections in your role and not so much on the energy balance concepts, we're here to help you bridge that gap.
Thanks. Thanks a lot, Scott. We have one last question. What is the base year for this submission?
You say the base year.
I think for the national projections, we have three years that we ask countries to report: 2030, 2040, and 2050. And the base, the latest historical year that we publish is 2023, right? In the questionnaire that we sent.
If you're talking about like GDP values,
but for the indicators,
like a base year, in table 2, when we ask for macroeconomic data and specifically for GDP growth rates, which you would use GDP projection values to use, we have switched over now to 2020 in US dollars in 2020, if that's what you're referring to.
Was this the question, Stanislav? Also, if anyone wants to take the floor to ask a question or to share your experience about this reporting, so that was the question, Scott.
Okay.
Yeah. If anyone wants to ask a question live. No question. So I think we can finish this webinar. So thank you again, everyone, for listening to us. We hope that this session was useful to help you understand how to report national projections. And as Scott said, we remain available for further inquiries that you may have. Also, if you would like a bilateral meeting with us to go through your country's projections, if you're having issues in reporting it, we are happy to organize bilateral meetings with some of you as needed. We hope to make this type of webinar more regular as needed. And thank you very much for having listened to us. So I'll give Scott the floor to say some closing words as well.
Yeah, I think you covered it. Yeah, we're happy to help as we learn more about your guys' projections. I know we had questions. We'd allocated more of a discussion piece for this to also ask questions from our side. We can do that in another venue. So conscious of people's time. So thanks for your questions, and yeah, feel free to add more by email.
Yeah, and one last point. So this webinar was recorded. We will share with you a link to a YouTube channel that you can watch again this session, and we will also get back to you with the questions that we have not been able to reply during the webinar by email. So you will hear very soon from us by email again. Thank you, everyone.
Okay. Yes.
Bye
Thank you so
bye.
much.